This is day 3 of Advent of Cyber 2024, and this challenge is called Even If I Wanted to Go, Their Vulnerabilities Wouldn't Allow It. Today's Advent of Cyber challenge follows a rather unfortunate series of events for the glitch. Here is a little passage which sets the scene for today's task. Late one Christmas evening, the glitch had a feeling, something forgotten as he stared at the ceiling. He got up out of bed and decided to check. A note on his wall, 2 days is now sec. With a click and a type, got his hotel and tickets, and sank off to sleep to the sound of some crickets. Luggage in hand, he arrived at Frosty Pines. To get to the conference, just follow the signs. Just as he was ready, the glitch got a fright. A RCE vulnerability on the website. He exploited it quick and made a report, but before he could send arrived his transport. In the Frosty Pines SOC, they saw an alert. This looked quite bad. They called an expert. The request came from a room, but they couldn't tell which. The log saved the day. It was the room of the glitch. In this task, we will cover how the SOC and their expert were able to find out what happened, Operation Blue, and how the glitch was able to gain access to the website in the first place, Operation Red. Let's get started, shall we? So the log objectives are to learn about log analysis and tools like ELK, learn about KQL and how it can be used to investigate logs using ELK, and learn about remote code execution and how this can be done via insecure file upload. So for this challenge, we need to turn on the virtual machine. Then we also need to go to the very top and start the attack box. So I will come back when both of these are ready to use. Okay, so it's all set up, so let's get started. So Operation Blue. In this section of the lesson, you'll take a look at what tools and knowledge is required for the Blue segment. That is, the investigation of the attack itself using tools which enables it to analyze the logs. For the first part of Operation Blue, we will demonstrate how to use ELK to analyze the logs of a demonstration web app, Wearable Rails. Feel free to follow along for practice. So log analysis and introducing ELK. Log analysis is crucial to Blue teaming work, as you have likely discovered through this year's Advent of Cyber. Analyzing logs can quickly become overwhelming, especially if you have multiple devices and services. ELK, or Elasticsearch, Logstash, and Kibana combines data analytics and processing tools to make analyzing logs much more manageable. ELK forms a dedicated stack that can aggregate logs from multiple sources into one central place. Explaining how ELK collates and processes these logs is out of the scope of today's room. However, if you wish to learn more, you could check out the Investigating ELK 101 room. For now, it's important to know that multiple processes behind the scenes achieve this. The first part of today's task is to investigate the attack on Frosty Pines Resort's hotel management system to see what it looks like to a Blue teamer. You will then test your web app skills by recreating the attack. So first, grab the link for the virtual machine. We then go into the attack box, open up Firefox, and go to this URL within there. Need to first open this up, paste the URL into here. Now it's in our clipboard within the virtual machine, and just open up a new tab and go to it. So for today's task, we'll use Kibana's Discover interface to review Apache 2 logs. To access this, simply click on the 3 lines located at the top left of the page to open the slide out tray, and under the Analytics heading, click on Discover. So the 3 lines, Analytics, Discover. We will need to select the collection that is relevant to us. A collection is a group of logs. For this stage of Operation Blue, we will be reviewing the logs present within the Wearable Rails collection. To select this collection, click on the drop down on the left of the display. So currently we've got Frosty Pine Resorts, but we need to drop this down and go Wearable Rails. Once you've done this, you'll be greeted with a screen saying, no results match your search criteria. This is because no logs have been ingested within the last 15 minutes. Do not panic, we will discuss how to change this shortly. To change the date and time, click the text located on the right side of the box that has the calendar. Select Absolute from the drop down. We can now select the start date and time. Next, click on the text on the right side of the arrow and repeat the process for the end date and time. So we'll select this. So 15 minutes ago, select that, Absolute, and go October 1st, and select midnight. Next we select now, and change that to Absolute again, and this will be October 1st, and 11:30 night. So with that selected, we now click Update, and we can see we have 811 hits at around 12 PM. So now that we can see some entries, let's go over the basics of the Kibana Discover UI. So at the top is the search bar, where we write queries using KQL. We have index pattern. An index pattern is a collection of logs. This can be from a specific host, or for example, multiple hosts with a similar purpose, such as multiple web servers. And in this case, the index pattern is all logs relating to wearable rails. We have on the left here fields. This pane shows us the fields that Elasticsearch has passed from the logs. So for example, timestamp, response type, and IP address. We have the timeline here. This visualization displays the event count over a period of time. Here is the documents or logs. These entries are the specific entries in the log file. And then at the top here was the time filter. We can use this to narrow down specific time frame absolute. Alternatively, we can search for logs based on relativity, i.e. last 7 days. So Kibana Query Language KQL is an easy to use language that can be used to search documents for values. For example, querying if a value within a field exists or matches a value. If you are familiar with Splunk, you may be thinking of SPL, Search Processing Language. So for example, you can use the field IP.address, and then you can filter based on the IP address 10.10.10.10. If we did that and update, well, nothing seemed to change, so I'm assuming they're all including the IP address. Let's add the IP address to, apparently there's no IP address that can be added. Okay, I guess it's just using an example and not an actual thing, so let's remove that. Alternatively, Kibana also allows using Lucene query, an advanced language that supports features such as fuzzy terms, searches for terms that are similar to one provided, regular expressions, etc. So for today's task, we will stick with KQL, which has been enabled by default. The table below contains a mini cheat sheet for KQL syntax that you may find helpful in today's task. So quotes are for an exact search, so try hack me. Asterisk is for wildcard searches, so you give it a string and then use the wildcard so it will search for anything that contains this and anything else after it. Use the OR so you have multiple conditions which could be true, then and for multiple conditions which must be true, and then colon is used to search a specific field and search a specific field for a certain value. So investigating web attack with ELK. Thanks to our extensive intrusion detection capabilities, our systems alerted the SOC team to a web shell being uploaded to Wearable Rails booking platform on October 1st, 2024. Our task is to review the web server logs to determine how the attack achieved this. If you like to follow along, then ensure you have Wearable Rails, which we do. So it wants us to change this to be October 2nd and at midnight. Doesn't seem to have changed anything, as it's just these logs. You'll see the logs have populated within the display. Please note that the quantity of entries hits in this task may differ to the amount on the practical VM. An incredibly beneficial feature of ELK is that we can filter out noise. A web server, especially a popular one, will likely have a large number of logs from user traffic. Completely unrelated to the attack, using the fields pane on the left, we can click on the plus and minus icons next to fields to show only that value or to remove it from the display respectively. So fun fact, clicking on these filters is actually just applying the relevant KQL syntax. So I might need to zoom out a little bit here just so we can clearly see. So in the just below, they're showing only logs for IP address of this one, and they are using client IP, so we'll add that to the selection here. And then they're only wanting to view this one. So they're adding that, and then they've also added the response in, and they don't want, so not 404, so we don't want errors within it. So using the timeline at the top, we can see a lot of activity from this IP address took place between 11:30 and 11:35, which we can see there. This is a good place for analysis. So each log can be expanded using the greater than icon located on the left of the document. Fortunately, the logs are pretty small in this instance, so we can browse through them to look for anything untoward. So let's add message and request into it, and straight away we can see shell.php is being used. So after some digging, a few logs stand out. Looking at the request field, we can see that a file named shell.php has been accessed with a few parameters, C and D, containing commands. These are likely to be commands input into some form of web shell. So now that we have an initial lead, let's use a search query to find all logs that contain shell.php. So using the search bar at the top, the query message and shell.php. So let's update that. And it seems like they've removed the filters, so we will remove those as well. And now we have the full our list of events, including the shell.php. So now, Operation Red. In this section, we will now take a look at the red aspect. In other words, the attack itself and how it was carried out. So why do websites allow file uploads? File uploads are everywhere on websites, and for good reason. Users often need to upload files like profile pictures, invoices, or other documents to update their accounts, send receipts, or submit claims. These features make the user experience smoother and more efficient. But while this is convenient, it also creates a risk if file uploads aren't handled properly. If not properly secured, this feature can open up various vulnerabilities attackers can exploit. File upload vulnerabilities. File upload vulnerabilities occur when a website doesn't properly handle the files that users upload. If the site doesn't check what kind of file is being uploaded, how big it is, or what it contains, it opens the door to all sorts of attacks. So for example, remote code execution, uploading a script that the server runs gives the attacker control over it, and cross-site scripting, uploading an HTML file that contains an XSS code which will steal a cookie and send it back to the attacker's server. These can happen if a site doesn't properly secure its file upload functionality. So why unrestricted file uploads are dangerous? Unrestricted file uploads can be particularly dangerous because they allow an attacker to upload any type of file. If the file's contents aren't properly validated, ensure only specific formats like PNG or JPEG are accepted, an attacker could upload a malicious script, such as a PHP file or an executable, that the server might process and run. This can lead to code execution on the server, allowing attackers to take over the system. Examples of abuse through unrestricted file uploads include uploading a script that the server executes, leading to remote code execution, uploading a crafted image file that triggers a vulnerability when processed by the server, or uploading a web shell and browsing to it directly using a browser. So, usage of weak credentials. One of the easiest way for attackers to break into systems is through weak or default credentials. This can be an open door for attackers to gain unauthorized access. Default credentials are often found in systems where administrators fail to change initial login details provided during setup. So for attackers, trying a few common usernames and passwords can lead to easy access. So examples of default credentials: admin, so username admin, administrator, admin at domain or guest, and password, same thing, admin, administrator, admin, guest. So what is remote code execution? Remote code execution happens when an attacker finds a way to run their own code on a system. This is a highly dangerous vulnerability because it can allow the attacker to take control of the system, exfiltrate sensitive data, or compromise other connected systems. What is a web shell? A web shell is a script that attackers upload to a vulnerable server, giving them remote control over it. Once a web shell is in place, attackers can run commands, manipulate files, and essentially use the compromised server as their own. They can even use it to launch attacks on other systems. So, for example, attackers could use a web shell to execute commands on the server, move laterally within the network, download sensitive data, or pivot to other services. A web shell typically gives the attacker a web-based interface to run commands. Still, in some cases, attackers may use a reverse shell to establish a direct connection back to their system, allowing them to control the compromised machine remotely. Once an attacker has this level of access, they might attempt privilege escalation to gain even more control, such as achieving root access or moving deeper into the network. So practice makes perfect. To understand how a file upload vulnerability can result in an RCE, the best approach is to get some hands-on experience with it. A handy and ethical way to do this is to find and download a reputable open source web application which has this vulnerability built into it. Many open source projects exist in places like GitHub, which can be run in your own environment to experiment and practice. In today's task, we will demonstrate achieving RCE via unrestricted file upload within an open source railway management system that has a vulnerability built into it. So exploiting RCE via file upload. Now we're going to go through how this vulnerability can be exploited. For now, you can just read along, but an opportunity to put this knowledge into practice is coming. Once an RCE vulnerability has been identified that can be exploited via the file upload, we now need to create a malicious file that will allow remote code execution when uploaded. So below is an example PHP file which can be uploaded to exploit this vulnerability. So using your favorite text editor, copy and paste the below code and save it as shell.php. May as well do this in the box. So let's create document and empty file, and we will name it shell.php. If we open that up in the text editor, we will copy and paste this HTML, place it into the clipboard, and then place it into shell.php and save. The above script, when accessed, displays an input field. Whatever is entered in this input field is then run against the underlying operating system using the system PHP function, and the output is displayed to the user. This is the perfect file to upload to the vulnerable rel system reservation application. The vulnerability is surrounding the upload of a new profile image. So to exploit it, we navigate to the profile picture page. So if we scroll further down, I think this is how we access it, because I don't think they ever showed us the link to it. So it's the IP of the virtual machine. So in my case, 10.10.5.239, and then ORRS-PHP. Okay, that's saying not found. Okay, well if you just put in the IP address by itself, it brings up the resort page. Okay, maybe we just continue reading through. So to exploit it, we navigate to the profile picture page. Instead of a new profile picture, we can upload our malicious PHP script and update our profile. In this case of this application, the RCE is possible through unrestricted file upload. Once this profile picture is uploaded and updated, it is stored in the admin assets image profile directory. The file can then be accessed directly via the IP address, localhost, project name, and then that directory. When this is accessed, we can then see the malicious code in action. Now, we can run commands directly against the operating system using this bar. The output will be displayed. For example, running the command pwd now returns the following, and returns that. So, making the most of it. Once the vulnerability has been exploited and you now have access to the operating system via a web shell, there are many next steps you can take depending on A, what your goal is, and B, what misconfigurations are present on the system, which will determine exactly what we can do. So here are examples of commands you could run once you've gained access, and why you might run them. So ls, give you an idea of what files directories surround you. Cat, a command used to output the contents of documents such as text files. pwd, present working directory, will give you an idea of where in the system you are. Who am I? Lets you know which user you are within the system. Hostname, the system name and potentially its role in the network. Uname-A will give you some system information like the OS, kernel version and more. ID, if the current user is assigned to any groups. ifconfig allows you to understand the system's network setup. This bash command is used to begin a reverse shell via bash. This netcat command allows you to begin a reverse shell via netcat. This find command finds the set user ID files, useful in privilege escalation attempts, as it can sometimes be leveraged to execute binary with privileges of its owner. And then this find command, also helpful in privilege escalation, attempts used to find files with writable permissions. So our task is, first must access Kibana to investigate the attack and answer the blue questions below. Then you'll proceed to the Frosty Pines Resort website and create the attack to answer the red questions and inform the developers what element of the website was vulnerable. So it is just this IP address, but they're wanting you to add it to the host file. So I guess we can do that. So copy this command, paste into the clipboard, then we will open up the terminal, and then we will paste it into here. So it's just saying our IP address. When we type in frostypines.thm in the web browser, it would actually go to this IP address. So if we do that, and then we go to here and do frostypines.thm, it now takes us to the Frosty Pines Resort. Okay, it seems like in the HTML, it's using this domain for its resources, which is why it looks like this without any of the styling, and then this one has all the styling. Okay, now it wants us to go to back to Elastic, switch to the Frosty Pines, and change the logs to be October 3rd between 11:30 and October 3rd, 12 o'clock. So update that. Okay, so for blue, where was the shell uploaded to? So we need a directory name. We've still got the search for shell.php, so we can see straight away it's in /media/images/rooms/shell.php. What IP address accessed the web shell? So in the log, there appears to be quite a few IP addresses. There's this one and then this one. I'm going to assume it's this one, as there's much more, so that would be 10.11.83.34, which is correct. Now red, what is the contents of flag.txt? So we need to go to Frosty Pines, and we need to upload the file. Did it actually say where to upload it? Okay, so it took me a little while to figure it out. So what I did, I removed the original search I had, I then added the client IP in, and then I noticed that they had visited /admin page. So I've gone there now, and we've got the admin page available. And if we click this drop down, we can add new room. Let's just call this shell so we can clearly see it, and browse for image. We can then, where did I save that file? I thought it was a desktop. Okay, all support. Okay, there we go. So now we do shell.php, and we'll add room. And now if we go to that room shell, can we select it? Now we directly go to it because we've uploaded the file. Okay, so ls execute. There's flag.txt there. We'll do cat.flag.txt. No, don't need that dot there. Cat space flag.txt. And we have now got the flag for that. So we'll submit it. And those are the answers completed. So that is day 3 of Advent of Cyber 2024 completed. If you like this video, make sure you like and subscribe.